Hello, welcome everybody. In today's VLSI course class, let's learn how to create a schematic in Virtuoso and a symbol, then how to set up the library as well as the ADE setup, including the simulation setup, transient analysis, and DC characteristics, everything. Okay. The very first thing is you have to put a path, the Virtuoso path that executable has to be put. Then that is given in the description, so you can refer the description, and then you have the model, the CDS dot library setup. So if you check my CDS dot library, this contains, I have added the solutions, then the demo, these two libraries are there, then including the installation CDS dot library that will bring analog library, sample library for various the primitive components or the simulation setup components, the stimulus, the DC voltage source, ground, VDD, the global VDD, global ground, everything it will be there. So you need to have this line plus your own library name. Okay, this has to be in the CDS dot library. Okay, then obviously there will be a model file, model library directory. So here you can see the various model. I'm going to use my models 2.cs file that will have the PCH and the NCH model. Okay, models, then my models.sch. See, you can see this NCH, which is a NMOS, and VTH is 1 volts. Then PCH, here the PCH, there's PMOS. So I'm going to use this model. So I'll explain you how to use that model. Okay. Now, so very first, so I'm setting the variable as $CD. Okay, so this it is showing this as a CD. Then I'm starting Virtuoso minus long cds1 dot long, because I do not want to write my log in my home directory. I want to write this log in my current working directory where I am invoking the Virtuoso, so that if there is any issues, I can go back and refer that file. Okay. Now this is called CAW. It opens a CAW, and here you go to Tools, Library Manager, and make sure that demo is created. Okay, and solution is already there, and it will bring all this analog all other libraries that is in the Cadence installation, like basic analog library. These are functional, these are very important. So now let me open a new test case. I'll create a new test case called inverter. Okay, so make sure that it is creating the library demo, and the view type is schematic, new name is schematic, then open with schematic here, not with the other application. ADL is for the simulation. Okay, now I will set up inverter 2 and click OK. It will bring up the Virtuoso schematic editor. Let me expand this. Then I have to create an instance. Okay, create instance where you can specify analog library, then NMOS4. I do not want NMOS, just NMOS, it should be NMOS and NMOS4 are the three terminal NMOS, and NMOS, this is NMOS, this is a 3 terminal device. So I do not want this one. Instead, I wanted NMOS 4 terminal, which is having source, drain, gate, and bulk. Okay, this is NMOS4. Then I have to select the model name. Model name, I already said the model NCH, that's the model name, which is the file available in the models directory, my models2.scs. Then width, I would specify 400 micron. Let's say, yeah, timing, I'll set it to 100 micron. I'll explain to you why I'm setting it intentionally. Then 10 micron, then click OK. Oh, this will be there. Then similarly, I need to select PMOS4. Okay. Then model name is PCH. Okay. Then width is 200 micron. Then length is 10 micron. And width I look at 100 micron. Okay. Okay. Then shortcut is W for the wire, or you can select this, create a new narrow wire and bring wire. You connect this one. So connect this wire together. Okay, connect this wire together. Bulk. Yeah. Connect this bulk. Source terminal. Okay, and connect both the gate together. And let's connect an wire in here. And then connect the wire. Okay. So then go to this. Make a input terminal as K. Yeah. Then connect to another one. Put this Y. Yeah, and Y is done. Make it symmetrical, which is most important. It will look nice and easy to understand. Then I'll put two input terminal. One is VDD, another one is CSS for the power supply of this MOS. So this is better to show it like this. Okay. This also, little top, then rotate. Okay. So VDD, VSS, input, output, everything is created. Do check and save. To do the check and save, then go to create cell view. From cell view to create a symbol. Okay, make sure that it is creating in the same library name inverted 2 and the same cell name inverted 2, and the library name is demo, and the from view name is schematic, to view name is symbol. Make sure that schematic symbol is selected, click OK. And you ask how left pin, right pins and top pins has to be. So say that VDD has to be top pin, bottom pin VSS. This way, it's easy to connect. This is the how in general it is created. You can see VDD, SS, A and Y. Okay. Then you can see on this one too. Now the schematic is created, right, for inverter 2. So you can go to inverter 2 in library manager. You can see schematic. Double click on the schematic will open. Double click on the symbol will open. Now I will create one more cell view that will have inverter 2 underscore test. Okay, test. And the view type is schematic. Make sure that it is in the demo library. Click OK. Then So what you have to do is bring that inverter 2, instantiate inverter 2 into this test bench. Okay, and let us connect one wire here, one wire here, one wire to VDD, one wire to VSS. Then we will bring some components to test. Okay, bring some component to test, right? And we pulse as well, and make sure that we pulse DC. Okay, let's connect. We pulse to this one. We bring this down. Connect ground pin. Connect here. Connect here. Connect here. And then let's make it symmetric. Okay. Okay. So let's maintain a little symmetry. Then connect W. Right. Okay. Not necessary, but it will look nice. Let's say if you want to select this ground pin, then it won't be selecting the ground net, it won't be selecting that pin. So if you have some gap, if you have some wire, right? So then let's bring the VDD. We'll connect VDD. Okay, connect VDD. Then let's bring the resistor at the output. Okay, small resistor output. Then I'll copy this ground and put it here. We need a ground for this one. Bring it down to make it look nice on one side straight line. So then VDC, I will put this as a design variable. We'll say VDC as a design variable. Then we'll enter no voltage 0, voltage 2 is V pulse. Okay. Then period is 1 micron, delay is 100 nanosecond, and the rise time is 150 nanosecond, fall time is 50 nanosecond, sorry, fall time is 50 nanosecond, pulse width is 1 micron, period should be 2 micron. Okay, so then we will put some name. This is input here, and output for this net name. Okay, and click check and save. So there is no error, everything is fine. Now we need to set up a test bench. So you can launch ADL. Then so make sure that your design is set. Demo inverter 2 test schematic. Click OK. Then go to simulator. Make sure that Spectre is simulator. There are other simulators. We are interested in the Spectre simulation. Okay. Then click on what you want to do. Transient analysis. Let me say stop time 10 microsecond. Okay. There are various options to set so that you don't have to worry now. Okay, and select the what outputs you want it to plot. I want to plot input, I want to plot output. Now current going through the resistors. That is, these are all going to be plotted immediately after the simulation, and we are running the 10 microseconds. There is one more missing. Variables copy from cell because we have set variables for this VDC and for this V pulse. So this will appear here. So we will say 5 volts is my supply voltage and V pulse also has to be 5 volts, right? Then there's one more final. Last one is model file setup. Is click browse button, go to models, then select the models that my models.p and make sure that it's showing PCH, PMOS, and NCH and MOS, right? Yeah, NCH and MOS. Then click OK. So you're done. Now you can save setup session, save state, and save the state as ADE underscore Spectre underscore I'll straight to click OK. Make sure that these are also and save, right? These options. Now go to simulation netlist. Create. Then you can see this M0 and M1. Okay, that is M0 and M1. The M0 and M1 is already there. This is M0 is NCH and M1 is PCH, and W is equal to 200 micron. This one is 100 micron and length is 10 micron each. Then you can see the simulator language is written Spectre. Global sub 0 and VDD 0 is down. Then parameters. So these are the parameters. VD is equal to 5, V pulse equal to 5. Then it is including the model parameters as well. So this is the model parameter. It will show up as a include. Okay. So this is a Spectre syntax, right? Then you go to the top level test bench. Then you can see this. See the I0. This is I0. Then this is V0. This is V0. V1 and R0. Everything is set. This is the simulator options. Okay. For the simulator options, we'll click on this one. Sorry, not this one. This is a simulator option, simulation option analog, where retal, abstall, iabstall, temp, everything is written. These are all default values. So you don't have to change anything. I will explain about this one in my theory class. This is important to know because if there is a convergence or error or single matrix error, so you need to know how to adjust this one, right? Then the next one is transient analysis. We know that we set up to 10 micron. It is showing the 10 micron. Then there is an option for the transient options. So there to say Spectre dot FC and IC is coming from this. So here also you don't have to touch any of these things unless there is a convergence error, right? Then click OK, and you can see these parameters from where this is coming. This is coming from outputs. Save all form, and you can see save equal to alpha be selected. This one is printing here, and these printing parameters are coming from this line, right? Okay. Then you are saving save R0 colon 1 because you are saving R0 colon 1. It is a mapped terminal with respect to the plus terminal, right? This is a Spectre internal terminal. Okay, so that's it. So now let's see, we will simulate and see the results. Are we getting the right results for the input that I'm specifying? I forgot one thing. Let me simulation stop. So make sure that your high performance is not set for APS but set for Spectre. Then run the simulation. So it will show the output, but you see what is missing. Output is switching between 0 to 700 millivolts, while the input is 0 to 5 volts, right? And the current is showing 755 microamperes. So this transistor is not well designed. What we have to do is I intentionally did this one. So you have to change the width of this one. So to make 5 edit table, then change the width of this one to 400 mega. Okay, let's see. Then sequencing, then you can run the simulation on the schematic itself and see how it will behave. So see now you can see the output is sorry, there's some issue. Yeah. Yeah, I think my load is this is not set correctly. So it also has to be changed to 20 micron. Then definitely stand run button. Then yeah, you see which. Yeah, now it is switching to 1.3 volts. There is a problem because we did not set this register. This register is not set correctly. So what you have to do is you increase the resistance value and run the simulation, and it will show up the full voltage of 5 volts. Now you can see it is switching to 5 volts, right? And the current is reduced to 48 microampere, right? So this is the transient simulation. Now we will run we will find out the DC characteristics. We will find out what is the DC margin. So for this we have to change this one to VDC, click apply, and DC voltage we can make it as a Vin, right? Okay, Vin. Then you can save. Then go to variables, copy from save view. V input will make it 5 volts for time being. So then go to DC, click DC, enable DC analysis, then design variable. I want to select a Vin as my design variable. So let's say I will start from 0 to 5 volts to check what is the nice. Do I get a nice nice margin? 0.01 volts, 0.00. Let's make 0.01 to make it a smooth, transfer characteristics. Then click netlist and run. This will show the this is the current. We're not interested in current. So here this is exactly switching at 2.5 volts, right? This will have a very good noise margin, right? So this I think I have explained in the theory classes how to calculate the transistor. So if you refer this one, this is how you calculated those things I have explained in the how to design the inverter, how to design the inverter for the build noise margin, right? Let us say if it is a bad design, then let's say I will change this one to something like 200 micron. Here 200 make. I'll change it to 200 micron. So length remains the same. You can save and hit netlist and run and see what is the transfer characteristics. See, switched here, right? This is not good. We switch to 2.8 volts instead of 2.5. So it has to be midpoint of the VDD. VDD is VDD is 5 volts. Then it has to correctly switch at 2.5 volts. So we have to change this width to 400 micrometer, right? Check and save, and the simulation is working fine, right? So it is exactly at 2.5 volts. Now session, save state, you save the state, and we are done with the simulation. So today we learn how to create a schematic symbol in Virtuoso schematic editor using the library manager, and then how to bring the ADE setup, how to set up the test bench for that inverter, and how to run the transient analysis, how to plot the output, how to run the DC characteristics, how to plot them, how to adjust the width of the transistor to get the noise margin, right? So yeah, this is all about this. If you have any questions, please let me know, whether it says setup information in ADE or a schematic, or if you have anything related to model file. So, so please send your comments, and thank you.